Well, hello and welcome to Mill Lab 11. This is going to be, we're going to use a different subprogram here. It's got down subprogram number one. I want to rename that. You know what, we'll worry about that later. Um, it is going to be subprogram number two. So what I've got here is subprogram is also commonly referred to as a subroutine, and it's a way of actually making the program a lot shorter. We call that optimizing the program. So I've got my standard startup block here. Nothing new up there at all. Um, you know, I am going to use a 3/4 diameter 90-degree spot drill so that I can locate the hole. Remember, spot drill does a really good job of locating holes, but there is some controversy about which does a better job of locating a hole, a center drill or a spot drill. Uh, I'm not going to get in that argument because it can get pretty heated sometimes, and I've seen people actually get very, very upset about that. So let's not do that. So we're going to use a 3/4 diameter 90-degree included angle spot drill, which will give us a 45-degree per side chamfer, which in this case they're asking for a 15 thousandths by 45-degree chamfer on all the counter bores. So I'm going to run this counter bore at 250 RPM. You don't ever, or excuse me, I'm going to run this. I'm going to say that a lot of times. I'm going to run this spot drill, sorry, at 250 RPM. Generally, there's I'm sure there's some formulas out there for spot drill RPMs. Wherever you work, I'm sure everybody's got what they like to run them at for what different material you're using. Uh, so remember, the 90-degree spot drill will both locate the hole and will also provide a countersink. So the Z depth on our spot drill has to be calculated up properly. So I've got my G43 activating my tool length offset. My H number, of course, matches my T number, which that's always going to have. So nothing is really new over here. Okay, let's hit Control S just in case I've not done anything. Okay, so the next move I'm going to make here is we've gone to X0, Y0, Z.1. So let's talk about the part. X0 and Y0 is going to be in the lower left hand corner. These are called baseline dimensioning. All right, they show you exactly where all the holes are at. We're not going to mill any outside, we're just going to drill these holes. That's all we're going to do using a subprogram. So as you can see, our counter bore, if we go over here, let's talk about what a counter bore is. So here's a counter bore, and that's why I was using it before, and the computer decided to go stupid on me, so I was stuck in the word counter bore. This part feature right here is a counter bore. Now, a counter bore is a larger hole that is located in the same location as a smaller hole. All right. Now, you can see they share the same center. That means they are concentric. That's a nice Latin term for you, concentric. So the biggest, most popular use of counterbores is to set the head of a socket head cap screw below the surface of the part. Another one, if you do any die work, and this would be a punch plate perhaps, it sets the head of the punch below that. Okay, so it makes this side all nice and flush. So we can see that this one's 125 thousandths deep. All right. Now, this doesn't have anything to do with the spot drill. I'm just telling you about the counterbore because we haven't done counterboring yet. Uh, and the diameter of the counterbore in this case is 625 thousandths or 5/8. Now, tools that produce counterbore, cutting tools that produce counterbores, well, just like countersinks, the part feature, being called a counterbore, is also produced by a tool that's known as a counterbore. I didn't make these rules. I'm sorry about that, but that's the way it is. Now, counterbores have pilots on them that are usually like very close to the size of this hole, and that locates, okay, the counterbore itself on the same center line as the hole that we're counterboring. Uh, we don't use counterbores a lot in CNC operations. Counterbores themselves as a cutting tool, okay, are used mostly on manual things like bridge ports or vertical turret mills or standard drill presses. You can use them real quick that way, and they're a very popular tool. They just they tend to run out, and if you're not really careful, they can actually hit on off location. You can end up breaking your counter bore, knocking everything out of a line. It's just a big mess. So your better use, the better tool to use to produce this part feature called a counter bore is going to be just a regular old end mill. Now you don't have to use a two flute or a center cutting end mill. I don't remember what I put in the instructions here. I'll pop them up in a minute. But the end mill typically produces a much better surface finish. All of them are going to produce this flat bottom, see, or if you want to say a square shoulder, we have a square shoulder there. So just any end mill will work, as long as you know what cutting speed you're going to use and feed per tooth, you'll be fine. And like I said, it generally does not have to be center cutting. Now, I should point out that orders of operation on machining would say that we would spot drill this hole, we would step drill this hole to size, which is 500,000 diameter, then we would counterbore it, then that's it. So we have to make this spot drill right here go deep enough to put a, what do I got here? I think I said it before. Let's look, 15 thousandths. Yeah, 15 thousandths by 45 degree per side chamfer on the counter bore itself. All right, so let's get going here. Excuse me. Okay, N70. Now, I've called it into location. Again, just to check that. Like I said, you could put a block skip up there. We don't talk much about block skips. Excuse me again. But in a lot of places they're used a lot. We haven't talked a bunch about them. This is a big an introductory CNC course, so you can learn more about block delete and block skip and things like that. Both of them, they're both called the same thing. But anyway, you would just put a / there if you didn't want the control. The control would just ignore this entire line. Well, I don't want it to ignore that line. Now, like on every part, do I want it to do that? A lot of people, if I had 3,000 parts, there's no way. I mean, it's a great setup. When I do that is because it goes right here, and I can see if it's really off. I can tell. Now, if it's 1,000th off, there's no way I can tell. But it just gives you some confidence. Once you've got it and you've got your stops and everything set up on your setup on the mill, you don't have to worry about this. So you can put that block skip in there and push the block skip button on the control, and it won't do that. So let's go ahead and get going. So the first thing we're going to do is we're going to go ahead and use, well, what do we use for a spot drill? Well, we're going to use a G82. Let's make sure we got this going here. G82. That is a drill with dwell. So let's calculate upper Z depth. It is going to be a minus value. So it's at 125 thousandths. Now, that's not how deep, that's how deep the counter bore is. We want this spot drill, okay, to go deep enough to put a 15 thousandths by 45 degree chamfer. So remember, always double this number because this is a per side. So 30 thousandths bigger than 5/8. So let's get our handy dandy calculator up there. Put in the decimal equivalency 5/8. Add 30 thousandths to it, I get 655. Now remember, that is not the depth. If you put that in there, you will scrap this part out. Okay, so we divide that by 2. Divided by 2 equals, that's how deep I should be. So I'll just copy that. Okay, I don't need that 5 there. Again, we don't need to be that anal about it. Control S if you haven't done it. So let's see what else we want here. All right, so we got G82, Z minus 0.327. Something I think I pointed out, this is just my formatting, Remember, the G82 has to have a feed, so you can put the F right here. I'll go ahead and put an F here. Let's figure up our feed. I'm going to go 2 inches a minute. Let's just go 2. Now, you don't have to put the 0 in there, but you definitely have to put that 2 in there. I think I've said that before. That decimal point. If you don't put that decimal point in there, it sees this. So that means for every time this tool goes around, it's going 2 10,000ths of an inch. That's going to be, you won't even see it move. You go, oh, what's the matter with this machine? Well, it's because you did that instead of that. Control S. Okay. Our plane, we're going to make it 0.1, just like always. Okay, so I'm going to go, let me see. I'm going down 327 thousandths at 2 inches per minute, and I've got an R plane of zero point 0.1. Now, when I look at that, one of the first things that you should have noticed right off, if you've been paying any attention to this, you're going, well, that's not right, Randall. That's not. The whole thing, I am going to cut, because what do we do? Anytime we use any of these G80 can drill cycles, the first move is to the location of the first hole. So let's go 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. Other people there may be more efficient ways to do it. I don't know. I'm just going to do that. So that's hole 1, hole 2, hole 3, hole 4, 5, and 6. So location of the first hole. We're already got G00 active right here. So I don't have to put that in there. Remember, it's modal until we change it. So I'm going to go what? I'm just going to move it right to there. So it looks like, and let's get this over into the location of the first hole. X is going to be 750. And remember, that's all you need to put space. That's just for clarity. Control S. And Y looks to be 600. And you could just put that. Okay? You could just put that and you'd be fine. As long as you got that decimal point in there. Otherwise, if you don't, you're going to go to 6 inches in Y, which is not going to be where that hole's at. All right, good enough. Control S, new line. N80. Oops, excuse me, N80. Yeah. And I'm just going to paste that stuff back there. Now I got my G82 going on here. I got my Z depth right. Remember, that's going to be half the diameter that you want your countersink to be. In this case, it ended up being 327. We're going to 2 inches. And like I said, you can put that 0 there if you want. I'll put it there just to, you can, but you don't have to. What else do we blah, 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 blah. Sorry. What else do we need with the G82? We need a dwell. And that's a P word. Remember, the P word means different things for different commands. But here we go. So that's a pretty big, I'm going to go, that is 1.5 seconds. 1001 and a half. That's it. Okay. So Control S, new line. All right, now at this particular point, I would do a subroutine call. I don't have to move it in location. It's already at the first hole. This is mandatory. So I'm going to put hole number 1 here. You always have to do that. All right. Now, that's going to put it in the first hole. Now, as you remember with the subprogram, we have to put something else here in this J82 line. Let's see see if somebody remembers. Because I'm going to make it do, I'm going to go, what is a subprogram call? You remember? M98P whatever. M98, and P is going to be the name of the subprogram. Now remember, a subprogram, a subroutine, the same thing. Subprogram is just another program, that little small short thing that you're going to store in the control. When the control sees this M98 and calls to whatever, it's going to go look for that and execute that program. All right, and we put a lot of cool stuff in there. You can also use subprograms for milling, but I've run out of time in this particular class, we usually don't do that in this class anyway. We just introduce you to them. So I don't know what I've got a subprogram down here. It's the same one. I got 8989, so we'll do that. 8989. Remember, that number has to match. Okay, your subprogram, or it won't work. Control S. So at that particular point, okay, so everything's in absolute. I'm not doing any. So right there, I've called my subroutine. Now in my subprogram, let's go back down here, because you're gonna look. I'm gonna put a G80 in here. Now I'm gonna go ahead and write the subprogram now. I'm gonna finish it real quick. So this is exactly the same as it was before. I just just changed things here. So it's a 6 hole. It's not a bolt hole circle. So let's get rid of that. Delete that, delete that. This is Mill Lab number 11. I want to get all this right. Control S. Let me see what else is going on. Stuff you want to know, really. Okay, and it is 6 holes. Okay, so the first one we already said was X was 0.75, and that's all you need to do. And Y was, of course, 0.6. All right. Control S. So there's my first hole location. So this is hole number 2. So what was x in hole number 2? It looks like it's 1.225, 1.225, and y is going to be 2.375. Right now I realize that that's probably not the most. You know what? 1, 2, 3, 4, 5, 6. That's it. So I'm not going to go to this hole just yet. I want to go to this hole. So x is 1.775. Y is going to be 1.5. Control S. Okay, that's hole number 2. Let's tab this back. Oops. Okay, Control S. There we go. So hole number 3, would be this hole. I'm just going to do it this way. So hole number 3 right here, where hole number 3. So let's check it out. Now, this is not a minus value. These are all pluses. There are no minus values in here. So let's see. Hole number 3, x is going to be 1.225, and y is going to be 2.375, or 2 3/8. Control S. There's hole 3. So going over here, that looks like that would be hole number 4. Now, the neat thing about this is, remember, we're already at the right, it's the right y location. It's a hard one to say, but we're already at the right y location. So we really don't have to do for hole number 4, we don't have to have any y coordinate at all. Delete. We're just going to move x. And x, again, is not a minus. So x looks like it's 2.75. Okay. Control S. That's all we need. That'll move it right to that hole right there. So 1, 2, 3, 4. So that should have been hole number 4. Again, hit Control S just to be sure. Let's go over here a little further and get that. That looks better right there. So that's hole number 4. This would be the next one, the next logical hole. That'll be hole number 5. So let's go down here. And let's see, hole number 5 is going to be, x is going to be 3.275. Okay, Control S. And y, of course, we moved y this time. Y is going to be 1.5. Let's double check that. Yeah, y is 1.5. So hole number 5, yep, no minus value there. Okay, that's all you need. Control S. Finally, hole number 6, which is this one right here. Let's see. My x value, again, the x value has changed, so I have to change that. It's back to 2.75, 2.75. Okay, and y is back at 0.6. Control S, and let's tab that over there. Okay, Control S. Okay, now here's that G80 that's going to cancel all of my can cycles. Okay, now remember that. So let's go over this subroutine structure once again. This is a simple one. Remember, the name of the program name of the subroutine is going to be exactly the same format. You can start with a capital O and then 4 to 5 digits. Remember, anything, these are comment statements, rem statements, it doesn't matter, they're in there. We end it with an M99. That says return to the main program, and don't forget your %sign. Okay, so Control S. There, I've got that done. There is my subprogram. No big deal. Okay, so I called it right here. All right, now you don't have to cancel the G80 because that was in the subprogram. So let's see, that saves you a little bit of time too. So I'm going to open up a block, and what am I, open up a block, says the blockhead. I'm going to go ahead and copy my tool change. Now, we're going to have to add some things, of course, but let me go ahead and get all my stuff here. Copy, go back over here, and we'll put a tool change right here. Paste. Okay, that always looks terrible when you first do that. Okay, now, what else do I want in here? Now, I'm going to resequence this, of course. So I'll just go N100. And I want an M05. An M5 will be fine. Okay, Control S, by the way. That's going to turn my spindle off. Another line. Yep, and then, of course, what? How about an M1 for an optional stop? Now, if you need that in there, I'll put that in there. Spindle stop. Okay, Control S, and this will give us a nice OPT. Remember, an optional stop is simply something that it's a really handy thing. Let's say you halfway through the shift you just got these whole spot drilled and it's time to go home. Well, you can come back to this right here, this, right here, look for this M1, just search for it in the control. I wish I could show you how to do that, and just run the rest of the stuff because we got everything we need down here. All right, so I'm going to hit Control S just in case. Yeah, there we go. So that's all we're going to need. So let's go ahead and change this. We're going to tool 2, which was, okay, a 3/8, and this is just going to be a drill. So Control S, that's 3/3, that ain't no good. Okay, Control S, yeah, there we go. Okay, so how fast do we run a 3/8 drill? Well, one more time. Okay, clear. I believe I was using a cutting speed of, let me see here, cutting speed of 100. Okay, so we're going to go 100 times, that's not a times, this is times 100, no, just clear it. 3.82 equals that, and again divided by 0.375, the diameter of the drill. I'm going to want it 1,000. That'll be fine. You don't have to be super anal about those RPMs most of the time. Control S. Okay, remember the T number has to match the H number. Control S. Now notice I brought it down to Z4. All right. Now I think I would like a clamp jump. Let's again assume that maybe I have some clamps up here. So if I'm on a clamp jump, all I have to do is go back up here. I'm going to put a G98 right here. G98. That's it. What that'll do is when this will wrap it down to 4 inches of the part, above the part. Then when my G82 kicks in, it'll wrap it down to 100 thousandths above the part. It will feed to 327 thousandths below the top of the part. Then it will wrap it back up to 100 thousandths. Then it'll wrap it back up to 4 inches above the part and go to the next hole location. So that's all you got to do. A G98, Control S if we haven't done it. Okay, so let's see here. At this particular point, watch what you're going, oh my God, is that all there is to it? Yeah, because guess what? Now, I'm going to show you something here. I'm going to take all this. We're going to copy it. Let's go back over here. Over here, I said. Okay. And open that up just for clarity. Remember, it doesn't care if you have a there. And I will resequence. Control S. I'm going to put that block skip symbol in there. Because I only need it to do that in the first hole. And I only need it to do in the first part. So we push a button and it'll ignore that. Now you're going, Randall, if it ignores that line, you won't be using any coolant. Right? Okay? Now there's some other things I forgot here. Well, I hope you figured it out. I have. But so all we have to do here is just put my M8 here. It won't hurt anything, but it allows us to skip that. Control S. You just put it right there. It won't matter. What you can't do is put 2 M codes on the same line. I wonder if I've told you that. Try and do it. Some of your, maybe a Morisiki might let you do that, but I guarantee you most of the case it won't. So we can block skip that if we want it. Now what else did we forget up here? Well, I was looking at this. We had an optional stop. I think I'm going to have to open up another line. N95. Okay, what did I forget? Well, I forgot to give it the old G28, didn't I? G28, and I'll do Z 4.0. That'll send the machine home. Control S, get all that in there. All right, so let's, again, we have to open it up here. I'll just copy that. I don't care. I'm going to resequence, copy. Go right here after my subprogram call. I'm going to put my G28 there, paste. All right, Control S. So there we go. That's really cool. So what I did this time is I put that little block delete symbol so that each time from now on I don't have to worry about that. Now I'm just going to copy all this because I've already done it. Remember, here's my program down here. Here's my subprogram. So guess what? Now, is that right? Well, there's some things wrong. Okay, but I've already done this. This will handle all the whole locations. That's the beauty of a subprogram. I do have to do some work on my G80. I don't want that to be a G82. I'm going to leave the G98 there. I want it to be G83. That's a Peck Drill cycle. How deep are we going? Well, it looks like we're going all the way through the part. The part's 500 thousandths thick. So let's go back up here, highlight this, bring this sucker back up here. So we're using a 3/8 drill, so 0.375 times 0.3, that's the length of the drill point. That's how long the drill point is. We have to compensate for that. It has to go past that. Uh, so, you know, that plus 500 thousandths. Okay. Now, that seems like a good number, and it is. I can double check it. Okay. I'll just do it one more time. 0.375 times 0.3 equals that, plus 0.5 equals that. Hey, but you know what? It doesn't hurt to add, and this is something I probably have not done a great job about, is probably doesn't hurt to add a little extra, a little security there. Oh, well, now that's interesting. Let's edit, undo. Bet you didn't do that. I have no idea how that happened. Doesn't matter. We'll do it one more time. So 0.375 times 0.3 equals that, plus 0.5 equals that. Okay, so I'm going to copy that, go over here, paste it, and then I'm going to change. Let's add. If I added 20 thousandths, that would be a 32. I really didn't have to do all that. There we go, Control S. Okay, feed for that drill is not going to be 2 inches per minute. Okay, no, it's not. So remember, what we do is for every 1/8 inch of drill diameter, we're going to use 2 thousandths per revolution feed, then convert that to inches per minute. So let's put 0.375, which is okay, that's 3/8, but I'll just do it anyway, divided by 0.125. What do you know? There's 3/8 and 3/8. There is order to the universe. Okay, then we take that and multiply it by 2 thousandths. Okay, and of course we get 6. So every time this drill goes around one complete revolution, it should move into the part 6 thousandths. Now we just multiply that by the RPM, which we said was 1,000, which you could have done most of this in your head probably. 6 inches. So our feed's going to be 6. Remember, 6.0. All right, Control S. Now let's see what else we need. We got our G98, we got our proper Z depth, we got our feed. Okay, we got an R plane. We do not need our P. Okay, we'll delete that. Now, you do need a Q in there. Now, sometimes I put the Q here, and remember, it doesn't really matter what order you put that in. I want to so don't get all anal at work and say, "Oh, the Q's not in the right place." No, the machine will read it as it needs it. I think I said use a Peck depth of, let's see here. Okay. Peck depth of 100 thousandths. That sounds about right. Okay. So that's a Q value. That's all you need to do. Control S. Now let's double check it. So I am going to go back and double check my coordinates on my subprogram because that would be stupid. So we went in here. We got our block skip here so that we don't need to do that. I put the M8 here just in case. Remember that's going to be a clamp jump or an initial point return, so it'll every time it drills a hole, it's going to wrap it back up to 4 inches above it. Okay, you may not need to do that. If there's no clamps in the way, don't put a G98 there. Don't worry about it. All right, we got a feed, we got a Q. Yeah, interesting that the Q value and the R value are the same. That doesn't always happen. I'm going to hit that Control S button just again. Then I call my subprogram, then G28, then I turn my spindle off, turn the optionals, and then provide an optional stop. All right, so that right there, that did tool number 2. So this time I'm going to go ahead and, all right, copy all of this again. Come back over here. Let's give us some room to work here, huh? All right, put it right there and paste it. Bring it back over. All right, so Let's see what we got here. Oh, we got all that going on, that going. This is tool 3. Let's change that real quick. This is going to be H3. We change that real quick. Okay, this is not going to be a 3/8 diameter drill. I believe I told you it was going to be a 1/2 inch diameter drill. Yeah, I know it is. 1/2 inch. Okay, Control S. So we got to calculate up our RPMs for 1/2 inch. Clear that out. So 100 by 3.82 equals this, divided by 0.5, 764. 765 will be fine. I'll copy it though here. Minimize that. Go right here and paste. Control S. Haven't done that in a while. I'm going to go 765 just because it bugs me. Okay. T3H3. Let me see. This 1/2 inch diameter drill. Everything's good there. Remember, I am going to resequence this. So now we're going to copy all this block right here. The whole thing. You're going, my gosh, this is easy. Yeah, it is once you get going at it. Let's give us some space to work here, huh? Enter one more. There we go. And paste. Okay. There. Got everything going on here. Now, this is not right. Okay. I do want to do this. I'm going to use actually, since I've already drilled this hole out, we call that step drilling, which means I'm just removing material. I don't really need to use a G83. I really don't. Now, for 500 thousandths thick with a 1/2 inch diameter, no, I don't. So I'm not going to use a G83. I'm just going to use plain old G81. Okay, the Z value is not right. Don't need that Q value because you'll get an error. There's no such thing as a Q with the G81. It won't tell you that. It won't say a Q's not. It'll say some sort of weird error depending on what programmer programmed it. And there ain't no such thing as one software engineer. There's like billions of them, and they all do different work, so they can all come up with different error messages. A lot of times your error messages don't even make any sense at all. You go, what the heck are they talking about? All right. So how deep do I take this? Well, let's go ahead and calculate up our drill point depths. I got 0.5 times 0.3 equals that. All right, so that's the length of my drill point, plus 0.5 equals this. So I'm going to copy that. Okay, that's how deep we're going to go. But again, I'm going to add a little bit of extra. How about 670? 20 thousandths isn't too much. Nobody will notice it. By the way, you don't need that 0 there. It's an insignificant digit. You do need that minus sign or you'll drill up. I swear to God, it will drill up. Control S. So there's my G98, G81. My feed is not correct. Calculate up my feed real quick. How many eighths? I'm going to do this. Just how many eighths are in a 1/2 inch? Well, there's 4. So 4 times 2 is 8 thousandths. So I'm just going to do 8. Well, easy for me to say. 8 thousandths multiplied times 765. Remember, I'm converting it to inches per minute here. 6.12. Okay. Now you could put a Peck drill in here. Let's say this was a really soft aluminum or some really gummy or maybe even brass, something like that. A G83 would probably be appropriate, but I don't think we need it. Control S. So then we call our subprogram M98 program P8989. It's actually O, but that means it's a subprogram. It's looking for it. Then we got our G28. Turn the spindle off and hit Control S again if you haven't done that. All right, so let's see what we just did there. Well, now we're ready for, well, we've only got one more tool left. We're going to do our counter bore. And remember, I'm using a 5/8 diameter non-center cutting end mill. It gives you, going to give you a better, oh, it makes a beautiful hole. And matter of fact, you can use, if you can, and if you have to ream holes, which we haven't talked about much about reamers, but reamers make very accurate holes, very round holes, and they make them very, very good surface finishes in there. An end mill, when you plunge it into the work correctly at the right feed, will actually come up with a really decent, a really decent surface finish, and it'll give you a really nice square bottom too, if that's important to you, which it is in a counterbore most of the time. So let's get us some room to work here again. Okay, great. So what I want to copy, well, I just want to copy what? It's going to do a tool change, so I'm going to copy my tool change block again. Bring this over here, put it right here, hit enter, paste, bring this back here, Control S. So that was tool 3, this is tool 4. So the first thing I always do is change that tool number, then change that H number. All right. So how fast are we going to run it? Let's see. If I said it was a 4 flute. I've got center cutting. It does not have to be, but okay. So it's 4 flute at 5 thousandths per feed. So let's get that. Yeah. So let's get back to here. Let's give us some more room to work here again. Control S if you haven't done that. So this is going to be well, might as well just put it here. 5/8, 4 flute and mill. Alright, Control S there, and that tells us what tool that is. Let's calculate our RPM up for that. Clear this sucker out. So again, I got 100 times 3.82. I'm laughing because I already know it's 382, but I'm doing it just so everybody knows. And divided by 0.625 equals 611 RPM. So I'm going to round that to 600. Okay, so I'll clear that out. I'll copy it first. What the heck. Now you don't want a decimal point. Remember this. I'm going to say this again. Never put decimal points in your S word. Alright, that will freak everything out. I mean, you'll get an error, and God knows what it'll say, like I said. So let's see what we've got all here. Yeah, we did that, we did that, we did all of that. So we got our, yep, so all we have to do is go back up here and copy this block again. And, okay, right here, paste it. Okay, hit Control S if you haven't done that. Give us some working room here. Alright, so another drill with dwell. We do again want this to dwell. So now 600, that's the right speed. So 682, that's moving pretty fast. I'm not going to need, first off, I'm not going to need a lot of dwell there. We'll come up with our feed here in a minute. So let's do our depth. Well, you look right here, you can see the depth of the counter bore is 125,000. So 125, Control S. How fast? Let me see here. How much feed? I'm sorry. Let me go clear that. So let me see. 4 flutes times 5 is 20 thousandths per revolution. 0.02. And see, times the RPM, which was 600. Multiply it by the RPM. 12 inches per minute. Don't forget the decimal point. Yeah, I know there's a lot of rules about that. Okay, so we have to put a P in there. This is going to be our dwell. Remember, G82 is drill with dwell. We want to give it time to go around there. So I'll just go 1 second. You know, later on, if I found out it didn't do that, Control S, by the way. Call our subprogram. I'd probably put that in there. Yep, should have done that. Yeah, I'm going to take that back. And I'll paste all that here. Yeah, because this is that class. Control S. Control S. And of course Control S. Now, call subprogram. Yeah, I'm not going to put the number in there. We just know it's a subprogram call. Alright, remember we've got the return to main program already in the subprogram. We've got the G80 already in there, so we don't have to cancel any of that stuff. So let's get this all back down here. All of this looks pretty good. Let's double check. We got our G98 again. That's going to give us a clamp jump. Probably, you know, we may not need it in this situation, but there we just so you can know how to use it. The Z depth is simple. It's 125 thousandths. It's a flat bottom. We don't have to remember end mills have flat bottoms or square bottoms if you want to call it that. So whatever that is, that's what that is. Okay, our value, of course, our retract plane. 0.1, and we're gonna dwell for a second. Then we send it home, turn off the spindle. Okay, so let me see here. Now that, in a nutshell, should be it. So I'm kind of ahead. I'm going to double check all this though because I did this pretty quick. Oh, Randall. Let's do that. Yeah. So G28 again, Z4. Okay, Control S, new line, N 130. I really don't need that. I'm just going to put my M30 right here. Okay, I do want to do something here. I have, obviously, there's another thing I forgot was to turn my coolant off. M9, Control S. So I have to go up here to all of these. M9, Control S. That's the beauty of these things. You can do this pretty quick. And I done that in the beginning. I wouldn't be doing it now, but seriously, for 4 tools, it's not taking me that long to do it. You'd be surprised how many times you forget to turn your coolant off. Okay, so let's see. Tool 1, turn my coolant off. Tool 2, turn my coolant off. Tool 3, turn my coolant off. Tool 4, yep, did not turn my coolant off. Control S if you haven't done that. Why do I have a G28 in there twice like that? That's very interesting. Do I have that in all the radios? No, I do not. I don't even need this line. Interesting. Delete. Delete. Control S. I don't know how I got it there, but I certainly got it there. You saw me. I'm looking at a lot of different things. Make sure I don't have any more 2G28s. That would really screw things up. It doesn't look like it. There we go. Now, yeah, fluid end mill. Bring that. Oh, that's actually it. Control S. Alright, so we've done all that. Now I can put my M30 in there. Okay, good. And of course, don't ever forget your percent sign. You'd be surprised how many people do that and wonder why your program won't even load. It won't load at all. Control S if you haven't done that. Alright, now you would not, remember, I'm going to delete some of these spaces. God knows how many I got between here and a lot. Come on. See the bar on the side over here is moving? There, we can see it. So you would not, and I repeat, you would not put your subprogram in the same line as your main program. This has to go in totally different. Okay, so also we need a percent sign there, don't we? Okay, Control S. We sure do. Remember percent sign at the beginning, percent sign at the end. Let's make sure we got our percent sign up there. We sure do. Okay. I'm just putting it in here so it would all, and these are my whole locations. I did say I was going to double check those, and you should always double check your whole locations, always, because boy, with a subprogram, you know, okay, so hole number 1, X is 750, Y is 0.6, that's correct. Hole number 2, X is 1.775, that's correct. Y is 1.5, that's correct. Hole number 3, X is 2.75. Okay. Now, I just double check that because, yeah, hole number 3, X is 1.225, Y is 2.375. So, yep. Hole number 4, all I have to do is move my X axis, not my Y, so I just have to put in the X's. 2.75, that's correct. Hole number 6, X would have been 3.275, right? Y is 1.5, that is correct. And finally, hole number 6 there, X would be 2.75 and Y would be 0.6. And good, I'm going to hit Control S again just in case. And remember, that M99 is incredibly important. It won't work without it. And the percent sign beginning and like that. That should actually be it. I'm not going to put this in NC Viewer because I know it will not run because NC Viewer will not do subprograms. It just won't. So what I am going to do, of course, is I'm getting rid of this. Goodbye. Okay. Go ahead and bring up Predator Editor. Let that come up there. Minimize that a second. Put your insertion point any place in here. Control A. Okay. And copy it. Paste it here. And again, process, resequence. I just take this, whatever they got there. Boom. Then hit Control A again and copy, or cut this time. You can close this off. No, I don't want to save it. And this is already it, so just go paste once you've got it highlighted. Okay. And let's see here. Control S. So let's double check and see where we're at here. Make sure we haven't got any craziness in here. When you're doing these things, boom, there you go. It's always best, especially once you get, in a shop environment. You may be out on the floor doing this on a laptop, and there's people banging things around, and your buddies are coming up and, talking to you about their girlfriends or their wives or their dogs or their trucks or something, and you're going, leave me alone, I'm trying to program. It's best if you have a nice quiet place. Some places will not give you a quiet place. That's just all there's to it. Remember that G98, okay, that is going to give us a clamp jump. So G82, again, drill with dwell. I'm not going to put all that on there. So yeah, I did use a 3/4 diameter 90-degree spot drill. And remember, we ended up with the right, I'm going to double check that one more time, clear it. So I had 5/8, which is 625 thousandths, plus 15 thousandths per side, which is 30, equals that, and divide that by 2. Since it's a 90-degree, that's what you can do, and that should be my depth, 327 thousandths. Give us a nice, once that hole's done, there should be a nice little 15 thousandths by 45-degree countersink on each side, or overall, whatever you want to call it. Well, it'd be per side. Okay, clear, gone. I believe that's it. Let's see if there's anything else stupid that I didn't do. I want to make sure that all my G28s have got an M9 in them. Okay. G28 for tool 1. Again, G28 for tool 2. G28 for tool 3. Yep. G28. Where's the G28 for tool 4? There's tool 4, G28. Okay. So, what do we do? Once again, we spot drilled. All right. We spot drilled. We step drilled with a 3/8 drill. I just divide it in half. Okay. Then, okay, step drilled with the 3/8 drill. All right. 3/4, 3/8. Then we drilled with a 1/2 inch because they're 1/2 inch diameter holes. And then we counterbored, which, you know what? Let me see here. Tool number, 5/8. And I'm going to put down 4 space Cobore, B-O-R-E. There we go. And of course I hit the shift, which whatever. Did it again. Control S. That looks good. All right. I feel comfortable with that. Comfortable enough for you to learn. I'll post this. Remember, there's a subprogram. You didn't have to calculate anything. Just showing you that this time we didn't have to do all of those crazy things, with all this stuff like that. Don't forget your M99 at the end of your subroutine, and it's a real good idea to also put that G80 in there. Now, you always have to go to that first hole. On that other one with the coordinate shift, we didn't. Oh, there is one thing I forgot. Goodness, I drilled. Okay, I sure did. On all of these, because I've used a subroutine, I drilled this hole right here, hole number 1, twice on all of these. There, good catch for me. L0. Yep, that is very important. L0, gosh. I knew I was talking about it, and then I got going here, so. L0, that means it will not drill that hole, okay, twice. And L0. You don't have to put a decimal point. Do not put a decimal point there. Control S. Now we're in good shape. And for some reason, I often wonder why that does that, but it does. All right, there we go. Now I'm confident that that'll work. I would have drilled this hole, like I said, hole number one. I would have drilled that hole lots of times. Well, twice, every single time. So I had four tools, right? So I'd have drilled that hole instead of four times. Anyway, let's not worry about it. I'm not going to figure it out. Put the L0 there, okay? Very important. That means don't do this. Don't repeat it. Okay? All right, that's good enough. Thank you for watching, and I'll see you on the very last middle one. All right.